Welcome to the deep dive. This is where we try to cut through all the noise, really stack up the evidence, and give you the facts you need to understand some of the biggest questions out there.
And today's question, well, it's a big one, a classic, really. The one that's driven so much curiosity for centuries. Are we alone?
Right. And you, our listener, you've probably seen the headlines lately. They're everywhere. These reports screaming about, the strongest evidence yet of life on some distant planet.
Oh, yeah, the hype machine definitely kicked into high gear with that one. It seems like every few years there's a new candidate, doesn't it? TRAPPIST-1, Kepler 452b, now this latest one.
Exactly. The news cycle just goes wild. But, and this is the crucial point, despite all the searching, all the excitement, the cold, hard fact is we still don't have that concrete, repeatable, 5 sigma proof of alien life. Not yet, anyway.
So our mission today is to kind of step back from that immediate hype. We want to look at the actual science, which is complex, let's be honest, and look at the historical challenges, the attempts we've made.
And also some of the, well, wilder theories. But theories that often have a certain logic to them, trying to explain either this great silence or maybe evidence of presence right here on Earth.
Yeah, we're pulling together research from sort of 3 main areas. First, there's the cutting-edge stuff, the exoplanet atmosphere analysis, this whole hunt for Hyson worlds.
Then there's the history, humanity's efforts to reach out, Voyager, SETI, sending messages and listening for replies.
And finally, we dive into the paradoxes and the, let's call them UAP theories, the Fermi paradox, the great filter idea, which is frankly terrifying.
All the way through to these detailed accounts, claims of concealment, maybe even contact. So by the end of this deep dive, hopefully you'll have a much clearer picture, be able to sort the breakthrough science from, well, just statistical noise or speculation. Okay, let's start with the science. The stuff that sparked this recent wave of excitement. We're focusing on K2-18b. It's a really fascinating planet, a mini Neptune type.
Right, discovered back in 2015. And it was found by the K2 mission, which itself has an amazing backstory.
It really does. I mean, the original Kepler telescope, its whole job was staring at one tiny patch of sky, right? Hunting for planets.
Yeah, incredibly precise. But then in 2013, disaster, or seeming disaster, 2 of its 4 reaction wheels failed. These are like gyroscopes that keep it pointed accurately. Losing 2 should have been game over.
You'd think so, but the NASA engineers, they got clever. They figured out how to use sunlight, the actual pressure from photons, as a sort of virtual third wheel.
It's incredible engineering. It meant Kepler couldn't stare fixedly anymore, but it could stabilize itself enough to observe different patches of the sky as it orbited. And that's how K2, the redefined mission, found K2-18b, a crippled telescope basically surfing on sunlight.
Amazing. So K2-18b itself, what makes it so interesting scientifically?
Well, first, its location. It orbits a red dwarf star, K2-18, about 124 light-years away. It takes about 33 days to go around. But it's the type of planet, this mini Neptune class.
Which we don't have in our solar system. We've got rocky planets like Earth, then giant gas planets like Jupiter and Neptune, nothing quite in between.
Yep. Exactly. K2-18b is about 2.6 times the radius of Earth, but 8.6 times the mass. Now, if you run the numbers...
That density is the key, isn't it? It tells you something about what it's made of.
Precisely. If it were all rock, given its size, it would have to be much heavier, much denser, because gravity would compress it more, maybe twice the mass it actually has.
And if it were just gas, like Neptune...
It'd be much lighter, less dense.
Yeah.
So its actual density suggests it's neither pure rock nor pure gas. There's something else making up a significant chunk of its mass, something relatively light.
Which led to the leading theory. Water.
A lot of water. The idea was this could be a planet with a potentially vast, deep ocean covering its surface, a water world.
But then there's the temperature problem. Initial calculations suggested it would be freezing, right? Like -8 degrees Celsius on average.
Correct. Based on its distance from its star, the water should be solid ice. Unless
it has a really thick atmosphere acting like a blanket.
Exactly. A super dense atmosphere trapping heat, creating a powerful greenhouse effect to keep that ocean liquid underneath. So suddenly, the big question became, what's in the atmosphere? And that needed better tools than K2.
Enter Hubble. Launched way back in 1990. And in 2018, Hubble made a big claim, didn't it? Water vapor.
It did. Huge headlines. But the scientific community was cautious, skeptical even.
Why the skepticism? Finding water vapor sounds pretty significant.
It was because of Hubble's limitations. It observes in a specific, fairly narrow slice of the infrared spectrum, about 1,100 to 1,700 nanometers. And in that particular window, the absorption signature of water vapor looks remarkably similar to methane.
Ah, so it could have been misidentified, like telling twins apart in bad lighting.
Sort of, yeah. You needed a wider view, higher resolution, to really distinguish the spectral fingerprints clearly, which requires understanding how they detect these things, transmission spectroscopy.
Right, explain that. It's a clever technique.
It really is. You wait for the planet to pass directly in front of its star, from our point of view. Then you measure the starlight very precisely. As the light passes through the planet's atmosphere, different atoms and molecules absorb very specific wavelengths, specific colors of light.
Like a barcode. Each chemical has its own unique pattern of missing light.
Exactly like a cosmic barcode. Sodium, for instance, blocks light at 589 nanometers. Water vapor absorbs strongly around 1400 nanometers. If you map out all these missing wavelengths across a broad spectrum, you can figure out what chemicals are in that atmosphere, even from 124 light-years away.
Okay, so while Hubble's data was a bit fuzzy, something else was happening in the background, theoretically. This Hyson world model.
Yes, this is a big theoretical step. Dr. Niku Madhusudan, originally from India, now at Cambridge, and his team. They noticed that planets like K218b, these mini-Neptunes, seem really common around red dwarf stars. So they developed this model, Hyson combining hydrogen and ocean.
So what's the core idea of a Hyson world?
It's a planet, likely a mini-Neptune, that has a deep global ocean. But crucially, its atmosphere is dominated by hydrogen, maybe 80–90% hydrogen and helium. And importantly, it's thick and warm.
Why is the hydrogen so important?
Because in that kind of thick atmosphere, hydrogen acts as a really potent greenhouse gas. It traps heat incredibly efficiently, creating that atmospheric blanket needed to keep the ocean liquid, even if the planet is relatively far from its star, or orbiting a cooler red dwarf.
And the model made a specific prediction, something that could be tested.
It did. A key prediction was about ammonia. Ammonia is highly soluble in water. So on a world with a massive deep ocean, any ammonia in the atmosphere should quickly dissolve into the water below.
Meaning you wouldn't expect to find much ammonia gas high up.
Exactly. The model predicted low atmospheric ammonia levels. If telescopes found lots of ammonia, it would challenge the Hyson model. If they found very little, it would support it.
And the implications for life, if these worlds exist.
Potentially huge. We're talking about worlds where life might not breathe oxygen, but hydrogen. We actually have microbes on Earth, extremophiles in deep-sea vents, for example, that metabolize hydrogen.
And the basic chemistry is plausible.
Very plausible. Think back to the Miller-Urey experiment in 1952. They zapped a mix of hydrogen, water vapor, and methane with electricity, simulating early Earth conditions.
And they created amino acids, the building blocks of proteins, of life.
Right, and those ingredients, hydrogen, water vapor, methane, are exactly what the Hyson model suggests could be abundant. So the basic chemical pathways for life's precursors are definitely there.
Which brings us to the James Webb Space Telescope. JWST, launched January 2022. It's often called Hubble's successor, but it's way more than that, isn't it?
Oh, absolutely. It's a quantum leap. Hubble sees a narrow infrared band. JWST sees a vast range from the edge of visible light, around 600 nanometers, way out to 28,000 nanometers in the mid-infrared.
And it's much more sensitive.
Hundreds, sometimes 1,000 times more sensitive than Hubble in certain wavelengths. To do that, it has to be incredibly cold. It operates at -223 Celsius, actively cooled, because infrared light is heat. If the telescope itself was warm, its own heat would swamp the faint signals from a planet light years away.
That incredible sensitivity is what delivered the big news in September 2023. What did JWST find in K218b's atmosphere?
Okay, so confirmed methane, confirmed carbon dioxide, standard stuff expected. But then it found a hint, a tentative detection of something else, dimethyl sulfide, DMS.
DMS. And why is that particular molecule so significant?
Because here on Earth, DMS is overwhelmingly produced by life, specifically marine life. Plankton, algae in the oceans release it. It's responsible for that characteristic smell of the seaside.
So finding it elsewhere, that's potentially a huge biosignature, much stronger than just methane.
Potentially, yes. Methane can come from geology, volcanoes. CO2 is common. But DMS, on Earth at least, is almost exclusively biological in the quantities needed to be detectable in an atmosphere. And the initial data suggested DMS might be present on K218b in concentrations thousands of times higher than in Earth's atmosphere. That's staggering, if true.
But there's always a but in science, isn't there? A certainty level.
Always. Especially for a claim this big. The current detection of DMS is what's called a 3 sigma level of confidence. That means there's about a 99.7% chance the signal's real, and not just random noise in the data.
Which sounds pretty certain to a layperson.
It does. But in physics and astronomy, especially for a discovery that would change everything, the gold standard is 5 sigma. That's 99.9994% certainty, a tiny fraction of a chance of being wrong. We're not there yet with DMS on K2-18b.
So that statistical gap, small as it sounds, is crucial. More observations are needed.
Absolutely. More time staring at K2-18b with JWST, refining the data, checking it across different wavelengths, particularly in the mid-infrared where DMS has other spectral lines. And there are other puzzles too.
Like the ammonia prediction.
Yes. We need to confirm if ammonia levels are indeed low, as the Hyson model predicts. If future observations find lots of ammonia, it makes the deep liquid ocean idea less likely. Maybe K2-18b isn't a water world after all. Maybe it's more like a gassy planet with weird atmospheric layers.
And there's another issue with the DMS itself. Isn't there something missing?
Yeah, a chemical byproduct. When DMS breaks down in an atmosphere like Earth's, one common byproduct is ethane. But so far, JWST hasn't detected ethane on K2-18b.
Which is weird if there's so much DMS.
It is. It raises questions. Is our understanding of the atmospheric chemistry there incomplete? Is the ethane being removed somehow? Or is the DMS detection itself maybe less certain than 3 sigma suggests? Or is the transmission spectroscopy model, how we interpret the light, missing something?
Yeah.
Lots of possibilities.
And crucially, could there be a non-biological way to make that much DMS on K2-18b?
That's the ultimate hurdle. We know DMS can be formed without life. We've seen tiny amounts in comets. And lab experiments have shown that if you shine UV light, which K2-18b gets from its star, onto a mix of hydrogen sulfide, methane, and CO2, all things likely present there, you can produce some DMS.
So the challenge is proving that no non-life process could possibly create the huge amounts that JWST data hints at.
Exactly. So the work now is happening on multiple fronts. Refining the Hyson theory, running lab experiments to check abiotic DMS production under K2-18b conditions, and critically, getting more and better data from JWST to really nail down that DMS signal and push for 5 sigma. It's peak science in action, exciting, but very careful.
Okay, so if, and it's still a big if, but if the Hyson model holds up and if DMS is confirmed as a biosignature from life, that implies life might actually be common out there. The universe could be teeming.
Right, which swings us right back around to that fundamental, almost nagging question that Enrico Fermi asked decades ago.
The Fermi paradox, where is everybody?
Exactly. Fermi was having lunch back in 1950, apparently discussing some UFO reports at the time. And he just did this back-of-the-envelope calculation in his head. The universe is vast, 13.8 billion years old, trillions of galaxies. The basic elements for life, carbon, hydrogen, oxygen, nitrogen, phosphorus, ovorates, they're everywhere, among the most common elements made in stars.
Statistically, life should have risen many times in many places.
And not just life, but intelligent life, civilizations capable of technology. Given the age of the universe, many should be far, far older and more advanced than us. They should have colonized the galaxy by now. Their presence should be obvious.
So Fermi just asked, very simply, where is everybody? The silence is the paradox.
And the scale is mind-boggling when you really think about it. We know the building blocks are common. NASA's Kepler mission data suggests at least 1 in 5 stars likely has an Earth-sized planet in the habitable zone, the Goldilocks zone where liquid water could exist.
And the timescales. Earth is 4.5 billion years old. The universe is nearly 3 times older.
Think about human progress. Look at the technological change in just the last 200 years compared to the 5,000 before that. It's exponential. Now imagine a civilization that reached our current level, say 300 million years ago.
Just 300 million years, the blink of an eye cosmically. What would they be capable of?
It's almost impossible to conceive. Harnessing the energy of entire stars, maybe manipulating space-time, interstellar travel that's routine, their engineering projects, their energy signatures. They should be detectable across vast distances. Yet we see nothing, hear nothing.
That silence leads to some pretty dark possibilities, doesn't it? This idea of the great filter.
Yes. The Great Filter Hypothesis suggests that there are critical bottlenecks or filters that life has to pass through on its journey from simple microbes to a galaxy-spanning civilization. And maybe one or more of these filters are incredibly difficult, perhaps almost impossible to overcome.
So what are some potential filters? We can think about ones we might have already passed, right?
Yeah, hopefully. Filter 1 could just be the formation of a stable planet in the first place.
Yeah.
In the right zone with the right chemistry lasting long enough. Filter 2 may be abiogenesis itself, the jump from non-living chemistry to the first self-replicating cell. That happened maybe 3.7 billion years ago here. but perhaps it's incredibly rare.
Then you've got the jump from single cells to complex multicellular life, that's filter 3, moving from the oceans onto land, filter 4, developing tools, language, abstract thought, intelligence itself, filter 5.
If the hardest filters, the great filter, are behind us, then it means we're incredibly lucky we won the cosmic lottery. We might be one of the first, or maybe even the only, intelligent species in our galaxy.
Yeah.
It's actually a somewhat comforting thought, in a lonely kind of way.
But the flip side is the truly scary possibility. What if the great filter is still ahead of us?
That's the chilling interpretation of the silence. It suggests that intelligent life might be common. Maybe discoveries like K2-18b will even confirm it. But perhaps all intelligent life eventually hits a wall it can't get past. It gets wiped out or destroys itself before it can spread across the stars.
And the most obvious candidate for a future filter is us. Self-destruction.
It seems depressingly plausible. Look at the 20th century. World War II killed maybe 3% of the global population using relatively primitive atomic bombs. Today, we have hydrogen bombs thousands of times more powerful, enough to cause extinction-level events.
Plus chemical weapons, biological weapons, and new threats on the horizon, like runaway AI or maybe misuse of quantum computing.
The filter hypothesis suggests that the very technological advancement needed for interstellar exploration inevitably brings with it the power for total self-annihilation. Maybe it's an inescapable trap that every civilization faces when it reaches a certain point. Exponential growth creates exponential risk.
And even if we avoid destroying ourselves, there are natural threats, right? External filters.
Absolutely. Runaway climate change could make the planet uninhabitable. A supervolcano eruption could plunge us into a volcanic winter. A massive asteroid impact, like the one that wiped out the dinosaurs. Or something truly cosmic, like a nearby star going supernova, or a gamma-ray burst sweeping across the solar system.
A GRB could literally sterilize the planet in an instant.
It could. Turn the whole surface to ash. No amount of intelligence saves you from that if you're caught in the beam. The filter theory suggests maybe these cosmic catastrophes are common enough to prevent any civilization from lasting long enough to go interstellar. The silence means maybe everyone else failed the test.
It's a heavy concept, the great filter. Thinking that the silence might mean doom is sobering. But while we contemplate that, humanity hasn't just been passively waiting. We've actively tried to reach out, haven't we, sending messages?
We have. The most famous examples are the Voyager probes. Voyager 1 and 2 launched back in 1977. An incredible mission timed perfectly.
They use that rare alignment of the outer planets, Jupiter, Saturn, Uranus, Neptune, something that only happens once every 175 years or so.
Exactly. It allowed them to use gravity assist. They flew close to each giant planet, using its gravity like a slingshot to gain speed and change direction without using much fuel. It was the only way to get them enough velocity to eventually escape the solar system.
And Voyager 2 is still the only spacecraft to have flown past Uranus and Neptune up close.
That's right. Voyager 1, though, is the furthest. It's currently over 24.7 billion kilometers away, well beyond Pluto. It officially crossed the boundary into interstellar space back in August 2012.
How did they know it crossed that boundary? The edge of the sun's influence? The heliosphere?
They used its plasma wave instrument. Inside the heliosphere, the density of charged particles, the plasma, is very low because it's dominated by the solar wind blowing outwards. When Voyager 1 crossed the boundary, the heliopause, it suddenly detected a massive jump, like a 40-fold increase in the density of electrons. That was the denser plasma of the interstellar medium, the space between the stars. Definitive proof it was out.
But its journey is nearing its end in terms of communication.
Sadly, yes. Its power comes from decaying plutonium in its radioisotope thermoelectric generators, or RTGs. That power output is steadily dropping. NASA engineers are shutting down instruments carefully to conserve energy, but estimates are it will likely fall completely silent around 2025, maybe a bit later. It'll keep coasting, of course, but as a dead probe, a silent ambassador.
Before Voyager, there were the Pioneer probes 10 and 11. They also carried a message, didn't they? The Pioneer plaque.
They did, a much simpler message, a small gold anodized aluminum plate, about 15 by 23 centimeters, designed to last for eons in space.
And what was on it?
5 diagrams, a map showing the sun's location relative to 14 pulsars, these rapidly spinning neutron stars with incredibly precise pulse rates, acting like cosmic clocks and landmarks. A diagram of our solar system with an arrow pointing from Pioneer's trajectory back to Earth, the third planet.
And the famous image of the humans.
Yes, line drawings of a nude man and woman standing next to the spacecraft outline to give a sense of scale. Very basic, but intended to show what we look like.
Voyager went much further with its golden record.
Much further. These were 12-inch gold-plated copper records like old LPs, but designed to last a billion years. They carried a rich multimedia message, curated by a committee led by Carl Sagan.
What kind of content?
A lot. 115 images and diagrams showing math, chemistry, our DNA, human anatomy, scenes from Earth, landmarks like the Taj Mahal and Great Wall. Interestingly, they specifically excluded any images depicting war or conflict. Want to put our best foot forward.
And sounds too.
Yes, 55 greetings in different languages, from ancient Sumerian to modern languages. A diverse selection of 28 pieces of music, Bach, Beethoven, Chuck Berry's Johnny B. Good, Louis Armstrong, traditional music from around the world, including an Indian classical piece, Rag Bhairavi, and 21 sounds of earth, wind, rain, volcanoes, animals, human sounds like laughter, tools, machines.
But how would an alien civilization even play this record or understand the images?
That's the big challenge. The record comes with instructions etched onto its cover diagrams showing how to build a player, the correct speed, 16 and 23 RPM, and crucially, how to decode the images. Because the Voyager only had about 69 kilobytes of memory, the images couldn't be stored digitally.
So how are they stored?
As audio signals. Essentially, the images were converted into analog sound wave forms, recorded line by line onto the record. The instructions show how to scan the audio signal and convert it back into a video picture, similar to old slow-scan television.
That sounds incredibly difficult to decipher without prior knowledge.
Almost impossibly difficult, even for humans. It's a complex puzzle embedded within the message itself. A test, perhaps.
So we've sent messages out. What about listening for messages coming in? That's the SETI effort.
Right, the search for extraterrestrial intelligence. Started seriously by Frank Drake back in the 1960s. The basic idea is simple. Advanced civilizations likely use radio waves for communication, just like us. These waves travel across interstellar distances at the speed of light.
And we've been broadcasting radio waves for over a century now. Our own signals are washing over nearby stars.
Exactly. Signals from early radio, television, radar. They've already reached thousands of stars, like Sirius, Proxima Centauri. So SETI reasoned, maybe older civilizations are broadcasting much more powerful, intentional signals. We just need to listen in the right way.
Let's sound anything.
Despite huge efforts, projects like Project Phoenix, listening to 800 nearby stars across billions of radio channels, collaborations with NASA using data from Kepler, JWST, Mars missions, the answer is still no. No confirmed, repeatable, unambiguously artificial signal from an alien intelligence.
There was the WOW signal.
The WOW signal in 1977 remains the most famous anomaly, a very strong, narrowband signal detected once, lasting 72 seconds, seemingly coming from the direction of Sagittarius. It matched many criteria for an artificial signal, but crucially it was never detected again, despite many attempts to re-observe that patch of sky. So it remains unexplained but not confirmed evidence.
So the silence persists, even when we're actively listening. Which brings us back to the paradox, and maybe more unconventional explanations. Okay, so if the science hints life might be common, K218b, but the paradox shows they aren't obviously here or communicating, for SETI silence, where does that leave us? The theories start to shift, don't they, from detection to maybe deliberate concealment.
Exactly. If they're out there and they're advanced, why the silence? This leads to ideas like the zoo hypothesis, proposed by John Ball back in 1973.
The zoo hypothesis, like we're animals in a cosmic zoo.
Sort of, yeah. The idea is that advanced civilizations exist, they know we're here, but they've adopted a strict non-interference policy. They're observing us, studying our development like zoologists studying animals in a nature reserve, but they deliberately avoid contact so as not to contaminate our natural evolution or societal development.
Because the moment they revealed themselves, everything would change for us. Our science, religion, politics, everything.
Precisely. It would be the biggest event in human history, and perhaps not necessarily for the better in their view. So they watch from a distance, maintaining the enclosure.
And there's a variation, the laboratory hypothesis.
A slightly different flavor. Here, Earth isn't just a reserve, it's an active experiment. Maybe they're studying how civilizations like ours handle critical challenges, the filters we talked about, war, resource depletion, AI, climate change. Perhaps they're collecting data or even subtly manipulating events, waiting for us to reach a certain stage.
It's interesting how these ideas echo concepts from religion or mythology, isn't it? Higher beings watching, testing.
It is a compelling parallel. Think about religious texts. The Bhagavad Gita, the Bible, the Quran. They often describe powerful non-human entities observing humanity, setting rules, judging actions. If a civilization is millions of years ahead of us, their technology might seem indistinguishable from magic, their understanding indistinguishable from divine knowledge. Are the gods just incredibly advanced aliens enforcing the zoo rules?
Which takes us to the ultimate concealment idea, the simulation hypothesis.
Right, popularized by thinkers like Nick Bostrom. What if none of this is real in the base sense? What if our entire universe, everything we experience, is just a highly sophisticated computer simulation created by an even more advanced post-human or alien civilization?
For what purpose? Entertainment, research, ancestor simulations.
Who knows? But if we're living in a simulation, then the Fermi paradox might just be a feature of the code. The simulators simply haven't programmed other obvious civilizations into our local instance of the universe. The silence is artificial because the simulation designers want it that way.
Okay, but all these concealment theories kind of rely on the idea that there's no credible evidence of them actually being here interacting with us. They assume the silence is total. But what about UFOs, or UAPs as they're now called?
That's the massive counterargument. If the Zulab simulation hypotheses are true, then every single UAP report has to be explained away as misidentification, natural phenomena, secret human tech, or hoaxes. But some cases are harder to dismiss.
Like the Nimitz incident in 2004, that seems pretty well documented.
It's arguably the most credible modern case, mainly because of the multiple sensors and highly trained military witnesses involved. U.S. Navy pilots from the USS Nimitz carrier group encountered objects that were tracked on advanced radar systems.
And these things moved in ways that shouldn't be possible.
Under the radar data and pilot accounts, yes. Objects were reported to drop from altitudes like 80,000 feet down to just above sea level, maybe 10, 15 feet, in literally seconds. The acceleration involved is far beyond any known aircraft or missile. The G-forces would be insane.
And the pilot saw something visually, too.
Yes. Commander David Fravor, a very experienced F-18 pilot, described seeing a disturbed patch of water, like something large was submerged, and hovering erratically above it was a white, smooth, oblong object. No wings, no visible propulsion. He called it the Tic Tac.
And it reacted to him.
Apparently. Fravor said as he flew towards it, the object oriented itself towards his jet and then accelerated away at a speed he described as unbelievable, vanishing almost instantly. It reportedly reappeared on radar 60 miles away moments later, and importantly, parts of the encounter were recorded on the jet's infrared targeting pods, the famous Flare-R, Gimbal, and Go Fast videos that were leaked and later declassified by the Pentagon.
Then you have mass sightings, like the Phoenix Lights in 1997.
A very different kind of event, not military radar, but thousands of civilian eyewitnesses across Arizona and Nevada on March 13, 1997. They reported seeing huge V-shaped or triangular formations of lights moving silently and slowly across the sky.
Descriptions were pretty dramatic, larger than multiple football fields, like a city block flying.
Some even compared it to the Star Destroyers from Star Wars. The official explanation offered later was military flares dropped during a training exercise.
But eyewitnesses strongly rejected that, right? Flares fall, they flicker, they don't hold perfect formation or glide silently for hours.
Correct. Many witnesses, including the then governor of Arizona, Fife Symington, dismissed the flare explanation outright based on what they saw. The discrepancy between the official story and the numerous consistent eyewitness accounts keeps the Phoenix Lights a major point of contention.
And we can't talk about this without mentioning Roswell, the classic case, 1947.
The foundational myth, really. A rancher, Mac Brazel, finds unusual debris in his field near Roswell Army Airfield in New Mexico. The base initially puts out a press release saying they've recovered a flying disc.
Which is pretty stunning for the time, but then they quickly retracted it.
Within 24 hours, the official story changed dramatically. It wasn't a disc, it was just a crashed weather balloon. What fuels the ongoing conspiracy theories is not just the alleged debris, described as strange metals, I-beams with weird markings, but the intense military reaction.
Especially the involvement of the 509th Bomb Group.
Exactly. That was the only unit in the world at that time equipped to deliver atomic bombs. Their immediate and heavy involvement in recovering mundane weather balloon debris seemed disproportionate to many, suggesting a cover-up of something far more significant, maybe captured alien technology or even bodies.
Despite all these persistent accounts, the official stance recently became even firmer, didn't it? The AARO report.
Yes, the All-Domain Anomaly Resolution Office, set up by the U.S. government specifically to investigate UAPs, released a comprehensive historical report in early 2024. It reviewed cases going all the way back to 1945.
And their conclusion?
Unequivocal. They stated they found zero evidence None to suggest any UAP sighting, including historical ones like Roswell or modern ones like Nimitz, involved extraterrestrial technology or represented any kind of alien visitation or presence. They concluded most sightings were misidentifications or lacked sufficient data.
Which, for believers or those convinced by cases like Nimitz, sounds like.
Like the ultimate confirmation of a cover-up. They see it not as the truth, but as the official reinforcement of the zoo boundary, denying the reality that's occasionally glimpsed. It deepens the divide rather than closing it.
If we entertain the idea that they are here, or at least visiting, not all theories about their intentions are benign, are they? There are darker suggestions, like animal mutilations.
Yes, the phenomenon often termed cattle mutilation, though other animals are sometimes involved. These reports, often from rural areas like the Dakotas, Colorado, Argentina, describe livestock, typically cattle, found dead under very strange circumstances.
What kind of circumstances?
Often specific organs are removed, eyes, tongues, genitals, rectums, with what's described as surgical or laser-like precision. Cuts are clean, cauterized, not ragged like predator attacks, and frequently the animal is found completely drained of blood with no blood stains on the ground nearby.
That sounds highly unusual. Vets have weighed in.
Yes, and some veterinarians involved in examining these cases have stated the precision is beyond known predators or conventional surgical tools available in the field. They've also noted that draining that much blood typically requires the animal to be alive with a beating heart during the process. Plus, the common observation that scavengers often avoid these specific carcasses is also strange.
So the theory connects this to aliens as some kind of sampling.
That's the unsettling theory, that these are not random attacks, but systematic biological sampling by a non-human intelligence, collecting tissue, blood, genetic material. Why? Unknown. Some speculate it's monitoring, research. Others fear it could be reconnaissance, a prelude to something involving humans. It's disturbing territory. And then there are theories suggesting a hidden history, that maybe non-human influence goes way back, or that we aren't even originally from Earth.
Like the ancient astronaut theories or ideas about lost technology.
Exactly. Take the pyramids of Giza again. Beyond the structural perfection and astronomical alignments with Orion's belt, there are weird mathematical coincidences. For example, the latitude of the Great Pyramid, in decimal degrees, is remarkably close to the value of the speed of light divided by 10 million. Is it a coincidence or encoded knowledge?
Suggesting a level of scientific understanding far beyond what conventional history assumes for that era.
Or look at ancient Indian texts, the Vedas and Puranas. They contain detailed descriptions of Vimanas. These are described as flying machines, sometimes capable of interstellar travel, using technologies like mercury vortex engines or anti-gravity. Some texts list dozens of types.
And the descriptions sometimes sound like modern UFO reports. Round, metallic, highly maneuverable.
They do. Again, is this mythology, poetic license, or garbled accounts of actual advanced technology, maybe from a lost human civilization or non-human visitors thousands of years ago?
There's also the reptilian theory, which sounds like pure sci-fi but has persisted.
It does sound outlandish. But the core idea in these theories is that a non-human, possibly reptilian or serpent-like race, sometimes connected to the Nagas of Hindu and Buddhist lore, were early inhabitants or colonizers of Earth, and still exist, perhaps hidden underground, undersea, or even disguised among us using shape-shifting abilities.
They point to figures like Maharishi Patanjali, the compiler of the Yoga Sutras, who is often depicted in ancient art as half-human, half-serpent.
Right. It's interpreting ancient myths and symbols as literal history of non-human entities. Highly speculative, of course, but part of the landscape of alternative explanations for the strangeness around us.
And the ultimate twist. Maybe we are the aliens.
That's another fascinating fringe idea. It argues human evolution seems oddly disjointed from other life on Earth. We seem poorly adapted physically, back problems from walking upright, sensitivity to sunlight, dependence on modifying our environment, clothes, houses, heating, rather than adapting to it.
We need GPS to navigate, unlike animals with innate direction sense.
Exactly. The argument is maybe humans originated elsewhere, perhaps Mars after some catastrophe or another system entirely, and were seeded or transplanted here long ago. Our feeling of not quite belonging is seen as a genetic memory of another home. Again, pure speculation, but it flips the "are we alone" question on its head.
And finally, ideas about glitches in reality. Time slips, parallel worlds.
These bleed into the truly paranormal, but often get linked to UAP discussions. Things like the alleged Philadelphia experiment in 1943. The story goes the U.S. Navy was testing radar and visibility tech on a ship, but accidentally caused teleportation, time travel, even fusing crew members with the ship's metal. Eventually denied, of course, but a persistent legend.
Or the man from Tord's story from 1954 Tokyo Airport. A man arrives with a valid-looking passport from a country called Tord, which doesn't exist. He points to it on a map between France and Spain, where Andorra is. He's detained, but vanishes from a guarded hotel room, along with his documents.
These kinds of stories suggest reality might be less stable than we think. Maybe accidental crossings between dimensions, timelines, or parallel universes occur. And some UAP sightings, or strange encounters, are brief glimpses into these other realities. So it's been quite a journey through all this. We started with the hard science, the potential biosignature on K218b. That's real data, real telescopes, but still needing that crucial 5 sigma confirmation. That's the frontier of our search out there.
And then we swung into the deep end of the silence, the Fermi paradox, the unsettling idea of the great filter possibly lying ahead of us, which led us right into these earthbound mysteries. The credible military UAP reports like Nimitz, the mass sightings like Phoenix, the historical enigmas like Roswell, and these darker theories of harvesting or hidden ancient influence.
We have these incredible tools now, like JWST peering light years away, and the legacy of Voyager still coasting through interstellar space. Yet the fundamental questions just get deeper, don't they?
They really do. Are these UAPs, these Tic Tacs doing impossible maneuvers, the first cracks appearing in the zoo hypothesis' concealment? Are we seeing visitors break the rules? Or are these phenomena something else entirely? Maybe natural atmospheric plasma effects we don't understand yet, or advanced, secret human technology.
The core dilemma is that gap between the potential abundance of life suggested by discoveries like K218b and the profound, deafening silence, coupled with these fleeting, bizarre, and often officially denied encounters here at home.
So maybe the final thought to leave our listeners with comes back to that great filter. If intelligent life struggles to survive its own technological adolescence, perhaps the most important question isn't just, are we alone, but can we survive ourselves? Considering our current path, incredible tech growth alongside escalating global tensions and environmental crises, are we the roadblock? Are we becoming the reason why the galaxy stays silent? Something to definitely mull over.